Python iterators. So this is lesson 19. Python iterators. An iterator is an object that contains a countable number of values. An iterator is an object that can be iterated upon, meaning that you can traverse through all the values. So maybe using a loop. Technically in Python, an iterator is an object which implements the iterator protocol, which consists of the methods iter and next. Iterator versus iterable. Lists, tuples, dictionaries, and sets are all iterable objects. They are iterable containers which you can get an iterator from. All these objects have a iter method which is used to get an iterator. So return an iterator from a tuple and print its value. So my tuple is equal to apple, banana, cherry. My my iterator is equal to iter and then my tuple. So this returns the iterator. And this one is an iterable object. So we print next my it, print next my it, print next my it. So it will print apple, banana, and then cherry. Even strings are iterable objects and can return an iterator. So strings are also iterable. So here we have my string equals banana, my equals iter, my string. So print next. So we can print next, and then it will print BANANA for banana. Looping through an iterator. So we can use a for loop to iterate through an iterable object. So iterate the values of a tuple. So my tuple is equal to apple, banana, cherry. For x in my tuple, print x, so apple, banana, cherry. So we have discussed this in the previous lessons. But here we are going to loop through an iterator, or the same, but this one in a string. So for x in my str, print x, so that will print BANANA. So just like what we have done in the previous one, but here we're using a loop. So to create an iterator, we can create an object class as an iterator. So you have to implement the methods iter and next to your object. As you have learned in the Python class object chapter, all classes have a function called init, which allows you to do something, so some initialization or initializing when the object is being created. The iter method acts similar. You can do operators, initializing, etc., but must always return the iterator object itself. The next method also allows you to do operations and must return the next item in the sequence. So let's have an example. So create an iterator that returns numbers starting with 1, and each sequence will increase by 1, returning 1, 2, 3, 4, etc. So we have class my numbers, so define iter self. So self a equals 1. So that means that if we create this one, the first value is 1, then return self. Then if we have the next function or the next method, so x is equal to self a plus 1. So we are adding 1 to self a, return x. So this will return a value, or we added 1 to x. So we have my class equals my numbers. Then my iter equals iter my class. So print next my iter. So that's 1. Next my iter, that's 2. So 3, 4, 5. So if we keep on printing and using the next method, this will always add 1 to our iterator. Stop iteration. The example above would continue forever if you have enough next statements, or if it was used in a for loop. To prevent the iteration to go on forever, we can use the stop iteration statement. So in this case, in the next method, we can add terminating condition to raise an error if the iteration is done a specified number of times. In this case, so in our iter, we initialize it to 1. Then next, so self a is lesser equal to 20. We assign it to x. add 1 to this and then return the variable x. So again, if you still remember, this x here is a reference to this object. So whatever we do with this object, we'll have that value. So that's why if we added 1 here, then it will also add 1 to x. So else we raise stop iteration. So my class is equal to my numbers, my iter equals to iter my class. So for x in my iter, print x, so it will automatically stop the iteration once we reach 20, or actually when a is greater than 20. But in print out, it will be 1 to 20. And that ends the iteration. So thank you very much for viewing this video.